Hello, everyone. Good morning, evening, and afternoon. Dear authors and invited guests, I welcome everyone to Technical Session 12F. My name is Amok Dhamdere, and I will be moderating this session. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is a great pleasure to welcome all of you to the 11th International Conference on Information and Communication Technology for Intelligent Systems, ICTIS 2026. The 11th edition of this conference is being organized in a hybrid mode. The physical event was held yesterday in Bangkok, Thailand, and the online event is being held through Zoom from the 9th to the 11th of April 2026. I hope all of you will be enjoying the knowledgeable and interactive sessions we have planned throughout the day. In this particular session, we will be having 10 presentations where each presenter will be given 10 minutes for presenting and 2 minutes for questions and answers. On the completion of around 8 to 9 minutes, I will be raising a gentle reminder as well. There is another request to all the participants that all of you please stay connected with us until the very end. And if you have any queries or updates, you can write it to me in the chat box of this meeting. Now, before we move ahead, I would like to introduce our session chair for today's session. So our session chair for today is Dr. Chaitali Shivare. Dr. Chaitali Shivare is an assistant professor at Vishwakarma Institute of Technology in Pune, India. She has over 12 years of rich experience in teaching, research, and academic leadership. She specializes in artificial intelligence, deep learning, and image processing, with research focusing on UAV-based surveillance and computer vision. Ma'am, we welcome you today with us, and I request you to give us your opening remarks.
Yes, thank you. Thank you for welcoming me, and I wish you a very all the best for this session, and to all the participants, all the best and present very well. Thank you.
Thank you so much, ma'am. It's great to have you with us. Without any further ado, we will now be starting with our presentations for today. So our first presenter for today is Dhanashri Amol Gore from the Marathwada Mitra Mandals College of Engineering in India. And the title of the research paper is A Comprehensive Survey of Phishing Detection Techniques, Machine Learning, Deep Learning, and Explainable AI Perspectives. Ma'am, I request you to unmute yourself and start presenting, please. Okay, I think she hasn't joined us yet. We can move on to the next one. So the next presentation would be done by Wu Nguyen. I'm sorry for any mispronunciations, but he belongs to the Ho Chi Minh City University of Technology in Vietnam. And the title of the research paper is A Rebalanced Multimodal Data Approach to Mortality Prediction for ICU Patients with Alcohol-Related Disorders. Sir, I request you to kindly unmute yourself and start presenting, please.
Yes, thank you. Good afternoon, everyone. I will begin my presentation. First, at the beginning, I would like to highlight the current situation in patient healthcare. As you can see, about 2.6 million deaths considered associated with issue in patient care, and 1 in 10 hospitalized patient is affected. And however, about 16% can be prevented. This show a critical need for effective solution to support early detection, risk prediction, and timely intervention in healthcare system. And here we can see that some statistics about using of AI in healthcare. And according to the WHO, AI is expected to become a key driver of innovation, equity, and ethical integrity. It helps to shape the future of modern healthcare. In our research, we focus on the ICU, which is a specialized department responsible for treating critical ill patients. Due to the severity of their condition, these patients require continuous monitoring and timely intervention. So, mortality prediction plays an important role in identifying high-risk patients at an early stage and allowing clinicians to optimize resource allocation and improve treatment decisions. Alcohol use is a major concern in ICU setting. These patients face a significant higher risk of mortality due to complication and poor treatment response. This highlights the importance of focusing on this vulnerable population in our study. And here are some challenges. As you can see, predicted mortality of ICU patients with alcohol-related disorders still remain limited. And we need to integrate multimodal ICU data. And another challenge is the data imbalance. In this work, we focus on data fusion and feature representation learning. We integrate multiple modality, including demographic information, diagnosis, chart and lab data, procedure, medication, and patient outcome. By combining these heterogeneous data sources, the model can capture more comprehensive patient information and learn more meaningful representation for accurate prediction. Another key challenge is data imbalance. This issue can bias model training and reduce the ability to accurately identify high-risk patients. To address this, techniques such as data engineering, feature selection, resampling, and hyperparameter optimization are applied. Existing machine learning approach in this area still remain limited. As we can see, other only review about alcohol-related risk without addressing mortality prediction directly. Some work only targets specific conditions such as cirrhosis. Overall, there is still a lack of comprehensive approaches for mortality prediction in ICU patients with alcohol-related disorder. Here, our contribution, we developed a mortality prediction model that focuses on ICU patients with alcohol-related disorder rather than the general ICU population. We also take the systematic matching of multiple prediction models, and we take the validation on both Mimic3 and Mimic4 databases. And also, we assess of both unimodal and multimodal settings. And this is our task definition. In this task, we aim to predict mortality risk for ICU patients with alcohol-related disorder. Specifically, we use medical data collected within the first DRO after ICU admission. For example, here is 24 hours as the observation window. And based on this early information, the model predicts whether the patient is at risk of death during the current ICU stay. And here, if the label will be 1, if the patient died during the ICU stay, and 0 otherwise. And this is our main pipeline. It contains about 3 different phases. In the first phase, we start with cohort data and select relevant modality. After going through many different phases, we get a feature vector. And the second phase, model construction, with the feature vector and modality-based label. We will go through the data rebalancing and then go through about 7 different supervised learning algorithms to create and choose the best prediction model. And in the final phase with the prediction model in phase 2, we will get the new data and to predict the whether the patient is at risk of ICU mortality or not. And we use about 7 different machine learning models for consideration. Between the machine learning model after experiment, CapBoost is selected as the primary model and combined with random undersampling as our rebalancing technique, so we can address the data imbalance. And this is some info about our experiment. We take the cohorts from the Mimic3 and Mimic4, and only ICU admission of patient with alcohol-related disorder ICD code equal F10 was returned. And this is about 6 different kind of data modality were used in our research. And this is some configuration. Here, please note that 3 different rebalancing technique was applied: random undersampling, random oversampling, and smoke and see. And there are some evaluation metrics are presented in table 3. We are IURC, IUPRC, sensitivity, macro precision, macro recall, and finally macro F1. We take about 4 different kind of experiment group. For example, in table 4, review the difficulty of mortality prediction for ICU patients with alcohol-related disorder. Here we consider both mimicry and mimic 4. As you can see, the metric like IUPAC and sensitivity remain very low. This indicates that many high-risk patients are still missed, which is costly in practice. Although several other metrics are relatively high, IUPAC and sensitivity require closer attention to better reflect prediction effectiveness for the minority class. And these challenges may be related to the specificity of the cohort, the data imbalance, the limited first 24-hour data, and the use of only a single modality. Therefore, our study proposed a rebalanced multimodal data approach as a more effective solution, and as demonstrated in the following research question group. For example, here we apply data modality, and you can see that it has improved the AUPRC metric very much for both mimicry and mimic 4. However, sensitivity values are still below 0.5. And this also shows a good signal for better examining each patient from many different perspectives with our corresponding data modality to enhance the task performance. This multimodal data approach is more effective for mimic 4 and not really stable for mimicry, as we can see in table 5. Compared to mimic 4, our cohort from mimicry is more challenging because the size is smaller and the data imbalance is more severe. From this situation, data imbalance handling is required in addition to data multimodality. And here we can see the result of the multimodal data approach combined with data rebalancing to mortality prediction. Now, please pay attention about the sensitivity metric. We can see that here sensitivity reached about more than 0.7 for mimicry and more than 0.88 for mimic 4, respectively. This significant improvement can identify
Excuse me, sir.
Yes.
Just a reminder, you have 2 more minutes left. Thank you. You can
Yes,
continue.
yes, thank you. Besides, the result highlight the effectiveness of rebalancing as our approach improves sensitivity while maintaining other metric value in higher range. And as a result, our rebalanced multimodal data approach is proved to be promising for the task. About group 3, in group 3, we present the result of how we evaluating different rebalancing technique. Precision recall and F1 for the minority class are used to analyze, and recall increase from no resampling to random undersampling, while precision decrease. It indicates a trade-off between detecting positive and avoiding false alarm. And finally, here is the table show the effectiveness of mortality prediction solution. And we can see that in mimicry and mimic 4 cat boost gets the most stable and effective solution for our research. And finally, in our research, we confirm the importance of combining multiple 24-hour data modality. And cat boost with random undersampling provided the most effective and consistent performance. And in the future, we aim to further refine the proposed approach with other unstructured data type like image or clinical text. And thank you for your listening.
Thank you so much for your presentation, sir.
Yes.
Dr. Sheware, any questions for
Yeah.
our speaker?
Yes. I wanted to ask for all the 3 experiments, was your data set same? Hello?
Hello.
Yeah, did you
Yes, sir.
get my
She
question?
means to ask if your data set was same for all the 3 experiments.
Yes. My
Okay.
data
And
set
what
as
features did you selected?
sorry again, it's very clearly.
She's asking what
What
features did you select?
Feature. Yes. Here we I select the feature related to demographic information, diagnosis, track lab, output medication, and finally procedure feature were used.
Okay, thank you.
Yes,
Okay, thank you so much for your presentation, sir.
yes, thank you.
Yes, we can now move on to the next presenter for today. So our next presenter is Ram Swagat B from the Satyabama Institute of Science and Technology in India. And the title of the research paper is AI-based framework for post-earthquake damage severity prediction. Sir, I request you to start presenting, please. Is there any problem, sir?
Yeah,
If you're facing any problems, you can share the PPT with me. I can present it from my side as well.
yeah. How to share with you, sir?
Can you give me a link in the chat box?
Yeah, a minute.
Or we can do another thing. If it takes time to solve that particular problem, we can take the presentation of another speaker in the meantime.
Can I share it as a PDF, sir?
Okay, yeah, you can share the PDF here
Yeah.
if possible.
Is it visible, sir?
Yeah, it's visible now. You
Yeah.
can continue. Just one small thing. Can you zoom in a little bit so we can see it a little better?
Wait.
No. I think, are you presenting on your phone, sir?
Yeah, sir.
Okay, so can you convert it into landscape and then present so it
Yeah, I
would
have
be.
converted it. Is
Oh
this?
yeah, it's now visible, sir. You can continue. Okay.
Yeah. Okay. Today I'm going to present our project title, an AI-based framework for post-earthquake damage severity prediction. This work focuses on using machine learning to quickly predict earthquake damage severity and support disaster management decisions. Our project abstract is about the traditional methods rely on manual surveys which are slow and inefficient. To solve this, we propose a machine learning based system using the XGBoost algorithm. Our model uses structured data such as earthquake magnitude, depth, soil type, and infrastructure details. The model achieved an accuracy of 83.33%, showing reliable performance in predicting whether an area is safe or damaged. This process enables faster and scalable disaster response without needing manual inspection. The need for advancements are the traditional seismic models only predict earthquake but not actual damage. With increasing urbanization damage, patterns are becoming more complex. Therefore, we need automated and intelligent systems that can provide real-time prediction using machine learning. The problem statement of this PPT is they depend on manual inspection, which is difficult after an earthquake. Also, existing models do not directly predict damage severity. So, we aim to develop a fast, automated, and data-driven system to predict damage severity accurately. The objectives are we focus on pre-processing data, improving features, and training an optimized XGBoost model. We evaluate performance using accuracy, precision, recall, and F1 score. This goal is to provide fast predictions to support disaster responding planning. The literacy survey is many models achieve high accuracy, but were complex and high, require large data sets or satellite data. Some models lacked explainability and were computationally expensive. The inferences are they also depend heavily on specific data types like satellite images. So we decided to build a simpler, efficient model using structured data. The proposed system used in my project is we use XGBoost clarifier to analyze parameters like magnitude, depth, soil, type, and infrastructure. The system automates prediction and provides fast, accurate results without manual inspection. The methodology and models we use here, these are the results, sir. Yeah.
Okay, thank you so much for your presentation, sir. Dr. Shivare, any questions?
No questions. You can go ahead.
Okay, well, thank you so much for your presentation, sir.
Thank you.
Yes, we can now move on to our next speaker. So our next speaker for today is Sheetal Wagmare from the Marathwada Mitra Mandal's College of Engineering in India. And the title of the research paper is An Empirical Analysis of Various Techniques for Object Detection and Video Summarization from CCTV Surveillance. Ma'am, I request you to kindly start presenting, please, with us at the moment. We can move on to the next speaker. So the next speaker will be Zarif bin Akhtar from the Institute of Electrical and Electronics Engineers in United States. And the title of the research paper is Beyond Perception, Advancements, Challenges, and Ethical Dimensions of AI and Computer Vision. Sir, I request you to start presenting, please.
Yes, good afternoon. Hope you can hear me and hope my slides are visible as well.
Yes, you are audible and your screen is visible as well. You can start presenting, please.
Okay, so this work is kind of like an extension for a lot of convolution for generative AI image processing, but mostly resemble towards computer vision. So one of the main things that I wanted to focus on this work was like the foundation models, the building blocks of what we currently have with generative AI and large language models. But in terms of vision perception, how well and good are they in terms of domain shifting and in terms of visual audiometry? How well refined are these in terms of specific requirements? So one of the main core disciplines in terms of AI is vision perception. This is where classical image processing, especially towards higher language models, now we're going multimodal. So we're going towards the evolution of visual audiometry. And especially like for complex and autonomous agents, for whether it is in the health industry, whether it is for autonomy, navigation, surveillance, especially in terms of decision making, there is a lot of context that is still missing because whether it is agentic AI, whether it is generative AI, they still rely on most of the vision architectures, including CNNs, vision transformers, YOLO, diffusion models. Now there's latent diffusion. So the generative model concept is still not explainable in a lot of terms. And in terms of deployment, when we try to go in diverse application domains, we usually have a lot of challenges. And the main responsiveness comes especially when we're going into edge computing, which will ultimately be our next layer of implementation. So this is where the main research gap comes from, and this is the thing that I wanted to tackle much more in deeper context. Because like if you look at all the state-of-the-art models that are currently available, most of the vision models have one issue. They're computationally very extensive. So despite all the impressive benchmarks that you see, 90% accuracy, 95, 98, you're able to have good benchmark on a lot of generalization of data sets, but you have to understand that these are all model driven. So what's the problem with that? So in terms of, let's say, your internal conflict with the model is that it has a lot of controlled hallucination. So what do you mean by hallucination? Because when there's an overflow of information, if you want to make a decision based on a certain impulse or a certain feature, it could be the case of perception in terms of what you're viewing. You cannot make that specific decision because it's programmed controllably. So how do you mitigate that? So I'm trying to kind of give like a bridge of architecture, and I have evidential, I guess you could say, contextuality, because I've tried to implement this in different frameworks, especially like with autonomous agents, and this works very well. So this is one of the reasons why I'm trying to move towards data-driven from a model-driven perspective. And a lot of you might say, well, all the machine learning models, deep learning models are based on model driven. We use them, we benchmark them, we cluster them. Yes, I fully agree with you. They're working well, they're giving you better benchmarks, but you have to understand at some certain point when you go in cross-dimensional domain, I'll give you a better example. Let's say if you're working with data sets using deep learning, whether it is YOLO, DeepVin, or maybe ResNet, when you're trying to cluster a certain data, you're basically trying to get a dendrite. The dendrogram is generated based on the perception that you're creating. You do the same kind of experimentation in food or agriculture or maybe like medical information, then you have more cross-labeling. So from a supervision standpoint, the unsupervised learning will be a much more better match because you're trying to figure out maybe a biomarker or a functional genomic for a certain feature. for DNA or deoxyribozoic nucleic acids. Then you have a cross-functional issue, which is where the architecture breaks. So if you don't have that kind of a leveling of interpretation, where do you need to do the pre-processing? What post-processing or qualitative analysis that you basically need to do in order to get that experimental setup? Because when you deploy that in a real-time environment, how can you configure? Because based on your patterns or your ResNet convolution layers, you don't have the full network. Sometimes there's loss function degradation, you lose a huge amount of scaling, and you're not able to compute. So one of the main reasons for this is because of the model-driven tasking of how the computer vision models have evolved. So whether you look at UNet, whether you look at mask, fast, RCNN, generative diffusion models, if you think about, for instance, like a microcontroller, you do not have that computational load. Yeah, maybe for the Jetson Nano, but it is also costly. So you cannot have any kind of computation ability performance degradation if you don't have these type of architectures. But if you want to use them, they're more computationally resourceful, but they're very highly exhaustive. So if you had a much more lightweight model, which could be trained on a certain feature, but based on the hardware, the body, it can be much more maneuvered, and your models and your tasks can be evaluated, and you can get explainability. Would that be better? Yes, of course. So this is where I guess you could say the data-driven perspective is much more better because, for instance, you have the Raspberry Pi 4, you have the Raspberry Pi 100. So the more scaling that you do, the more price is going to evolve. But if you had a limited GPU in terms of computational and graphical interpretation, if you do from a data-driven standpoint and make a foundation model based on a different architecture, but keep it concise for the matter of generalization, it will give you a much more higher percentage of score. And as you can see from the model training that we have done, we have tested this for medical data sets, we have tested this for autonomous agents, we've tested this for robotical implants, and they gave a very good dice score. And also in terms of power consumption, these types of models were able to produce very good results. Now you might be asking, okay, so what is the applicational deployability? I'll give you a very simple example. I'm actually working on this field currently right now. For autonomous agents to be fully autonomous, what do you need the most? You need its visual audiometry of perception. How do you do perception? You use computational modeling and you give it kind of like a hive mind or maybe a TPS issue, which it can generate from. This is where generative AI comes in. So now think of you have a mission to perform. Your mission can change at any given time. But if you do a data-driven standpoint directly on the model itself and keep the model in a scaling informatics that it is context aware and it understands its features. So based on the requirement, you can do certain tasks. This is why explainability is more required. Because if you think about a diffusion model appertizing on that particular autonomy, what would be the case? Each iterative time, all the computation you are putting in on every single image, you need to add noise. And over time, you need to do epoching, and then the segmentation goes out of context. And then when you have more data input, you are becoming more self-constrained. But what if it was that my model was trained on the idea of generalization to determine the uncertainty for that particular model? So based on the requirement, let's say your point of interest change, or you need to label a certain feature, or you need to detect some kind of signal anomaly, you could have done this in a much more age deploymental way. This is why we tested with both the NVIDIA Jetson Nano and with Raspberry Pi 4, because the Jetson Nano has its own integrated GPU, so it can run much more higher benchmarks in terms of those convolutions. So even with a lightweight model, the age deployment was much more feasible and it gave almost the similar amount of results.
Excuse me,
So
sir.
yes.
Nothing, just a reminder that you have 2 more
Yes,
minutes left.
yes, no worries. I'm almost finished. So,
Thank
like
you.
in terms of the innovations, so this is what we are trying to like give on the context of the self-aware framework. That if you want to include AI in terms of the edge computing, where ultimately IoT devices are going to play a huge part. So whether it is the AR or healthcare industry, surveillance, security, the automotive industry, if we try to create the foundational model directly from a data-driven standpoint with Vision AI, some of the requirements needs to be a little bit more concise, because if you have more generalizability, you can have less task intensive processes, and you can use this in terms of domain shifting. So in order to create this kind of foundation models, I think all of us should like focus more on data driven standpoints, because yes, there are a lot of models available, but if we can go back to its original root to design a much more functional vision odometry based from a data driven model standpoint, we can evaluate much more better improvements. And over time, if these models are integrated into large language models and vision perception, they can evolve and they can give much more better context aware. And we have a lot of tools, libraries that we can use from. So why not try to implement these kind of things directly from the foundation itself? And perhaps maybe we can have more better realization, because if you look at some of the state-of-the-art models that's already available, the main issue that everybody faces is computational exhaustion. But if we can deploy these kinds of models from the data-driven standpoint and destroy the blocking usage in terms of loss functional ability, and we can still adapt to new computational rise or the cost and the surveillance and also the multimodality, this could be a fair way for us to move towards a different framework and a new architecture. So these are kind of the new experiments that I'm currently doing. I have some results which I was sharing with you, but hopefully over time I will try to deploy this with electronic health records, edge computing devices, and once those results are available, hopefully I can get them resourced and published as well. So that kind of is the main goal of this research context, you could say. So this is where I end my discussion of my presentation. And thank you very much for your time. If you have any questions further, please feel free to knock out and reach out to me. And thank you very much for your attention.
Thank you. Thank you so much for your presentation, sir. Dr. Shivare, any questions?
Yes. Is your system implemented?
Yes, ma'am. My system is already being implemented under a European project, which is called for Self-Awareness Framework. And currently we are working with DJI and Drone Hopper to like implement this in UAVs to see how good are we able to execute based on the requirements that they have. We're currently trying to solve the traveling salesman problem with swarm intelligence. So that's up till the experimentations that we have done in both UniG and UC3M. So I'm currently working towards that one.
Okay. And other than swarm optimization, any other optimization algorithm have you thought for this?
I actually have implemented a new hybrid KLT detection and tracking system. It got accepted in ICASP. I will be going on May to present that work. So I kind of like designed I guess you could say a different computer vision model, but a lightweight version which you can use. But it's still in a work in progress because we did this experiment for like UAV missions. So I now want to include that what happens when I do this in 3D environment with more uncertainties, especially with obstacles. And if I get the similar results that I did with my hybrid KLT, I should be able to give more better concise and clarify that these models will probably be the next step in order of foundations.
Okay. Okay. Thank you.
Thank you very much, ma'am.
Thank you for your presentation, sir. It was quite interesting. We have one of our previous speakers joining us right now. So the presentation will be done by Dhanashri Amol Gore from the Marathwada Mitra Mandal's College of Engineering in India. And the title of the research paper is A Comprehensive Survey of Phishing Detection Techniques, Machine Learning, Deep Learning, and Explainable AI Perspectives. Ma'am, I request you to kindly unmute yourself and start presenting, please.
Yes, sir. Thank you, sir. I'm
You're
audible?
very welcome. Yes, ma'am, you are audible to me. Your screen is visible as well now, so you can start.
Yes, sir. So I'm Dhanashri Gore from Marathwada Mitra Mandal College of Engineering, PhD scholar at University of Technology, Jaipur. I'm discussing about phishing detection using machine learning, deep learning, and comprehensive survey with an explainable AI integration systems. This is a survey about an phishing detection system. This is an agenda of my survey presentation. So, phishing continues to pose a serious threat to digital security by exploiting human vulnerability to steal confidential data through disruptive online interactions. Traditional detection methods often all short on identifying the advanced phishing strategies. These survey present an comprehensive overview of phishing detection techniques with a strong focus on modern and multi-layer machine learning, deep learning based solutions. The proposed system have an three or four layers of architectures can be a framework include a key stages data collection, preparations, model training, detection, prediction, and explainability. In the first layer, email, URL, and metadata are collected to process as a data and extracting the features. The second layer involves model training using both machine learning and classifiers such as a random forest, SVM, Naive Bayes, and KNN. And for the deep learning architectures like CNN, RNN, and LSTM, these models feed into the third layer where the phishing is detected and classified finally to the fourth layer integrated explainable AI. Method like line, sharp, anchor to the enhanced model transparency and interoperability. This survey evaluates the effective and limitations of each layer, highlights their need to be explained and scalable where the adaptive phishing detection system will be generated. After it sorry, sir. Screen is visible, sir?
Yes, ma'am, your screen is visible.
I can't see that. That's okay. So basically, what is phishing? Definition and scale of phishing. Phishing is an cyber attack where the advertised importance trusted to entities to steal credentials, financial data, or installment malware. Like as an, it is an abundant things, or it can be an anomaly detection can be done in a phishing. If we are going another way or a wrong way, that can be a phishing, that can be anomaly kind of things. So overall, 3.4 billion phishing emails are sent daily worldwide. Phishing account for the 90% plus of all data branches. Losses exceeded 52 billions of globally in 2022 alone on only for the 1 year. So we can analyze or we can think that what type of phishing can be done, what type of fraud will be done in the last previous and nowadays. Attack targeted can be emails, URLs, SMS, and voice calls, etc. So why AI power detection can be used for that phishing detection? Traditional rules based filter fails again the zero-day phishing. Attack involves tactic faster than the manual updates. ML and DL automated features learning from the massive dataset. Real-time detection at the scale is only feasible with AI. XI adds transparency, uh, explain why something is phishing. So we are trying to use the XI for the why question and how it happened in our database, why that attacks happen, why our data is corrupted or thief by the third party. Here in a scope or objective of this survey ML techniques, review a random forest, SVM, nearby scan, these type of algorithm for the phishing detection across the email and URL. Second is in survey deep learning. We are using a deep learning algorithm, CNN, RNN, LSTM architectures for the automatic feature extraction and the pattern recognition. Evaluate a data set, compare a benchmark data set, phishing tanks, UCI, ICSX, size, diversity, recency, class balance, like that. Fourth is an access XAI integration. Examine how Lime and Sharp and Anchor improve the interoperability of phishing predictions. Identify the research gap. We can find an pinpoint and limitation in existing work and outline the direction for the future improvement. This is a literature survey which I refer a paper, reference paper for my survey by for the phishing detection. So this type of survey I have done, and from that I have concluded, or I have summarized some techniques by the period. So in 2019-20, URL based ML, SVM, random forest, and URL lexical features gives an 96% accuracy UCI phishing datasets. After that, 2020-21, email plus NLP use Neva bias, LSTM, and EML content. LSTM surpassed the NB by 4 to 6% on Enron dataset. 2021-22 deep learning CNN use raw URL characteristic achieve 98.3 reduce 98.3 data accuracy, reduce a manual featuring engineering and significantly. 2023 the hybrid ensemble RF plus LSTM ensemble reaches 99.1 accuracy. F1 combined structural semantic features. XI integration in 23-24, sharpen line applied to a black box model, improve user trust and regulatory alignment. Regarding on machine learning techniques, there is an algorithm like random forest, SVM, near bias, and KNN gives an accuracy with a 97.8% strength of random forest is handle high dimensional features well robust and robust to noise. Limitations gave then high memory, slow for real-time prediction at scale. SVM gives an 96.4 accuracy, excellent binary classification, effective on URL feature is the strength, and the limitation with the poor scalability with a very large data set. Bias 93.1 accuracy, fast training, work well with the text and email classification is the strength, and with the limitation, independence, assumption, weakness, performance on the correlated features. As per KNN 94.6, accuracy strength is the simple, no training phases, work with a few samples, very slow and interface and sensitive to irrelevant features is the limitations. Regarding deep learning approaches, CNN, RNN, LSTM, CNN is a convolution network, gives an best accuracy 9.83, operate on raw URL character sequence, learn patterns automatically without a manual featuring engineering. Use cases, URL characteristics and label detections in the aspects of RNN, recurrent neural networks, best accuracy 97.1, capture sequential dependencies in email text, process token in order, useful for understanding and context in message. Use our email content classifications, LSTM, long short term memory, accuracy gives them 98.9, extend RNN with the gating, retain long range dependencies based for the capturing subtle and causes across the long email threads, use cases, long form phishing email analysis. Apart from the XAI, explainable XAI in phishing detection, line sharp and
Excuse me,
anchor.
ma'am.
Yes, sir.
Just a reminder, you have 2 more minutes left.
Yes,
Thank
sir.
you.
Yes, sir. Yes, sir. I'll proceed. So this is a research gap. So we can find out how and why year wise I have already done with a literature survey. So research direction can be a continuous learning system, age AI real time detection, adversary robust models, multi-angular and cultural NLPs, multi-model fusion architecture, excite driven active learning, etc. So I have to conclude this survey highlight a comprehensive layered framework, integrated data collection, model training, detection, and explainability to tackle a phishing threat effectively. The inclusion of diverse machine learning, deep learning models, enhanced detection, accuracy by learning from the complex pattern in the phishing data. Furthermore, the integration and explainable AI techniques provide much needed transparency, enable stakeholders to understand the trusted model detection. The layer design ensure the modularity, scalability, flexibility, accommodating new threats and model over time. While current models show a promise, future research must focus on the real-time detection, cross-platform adaptability, improve the interoperability. So these are the references. Thank you. Thank you so much.
Okay, thank you so much for your presentation, ma'am. Dr. Shivare, any questions for her?
Yeah, I wanted to ask how many records did your data set have?
Ma'am, from my mail and my friend's mail, I have like 2 GB at data set. I have revised that data or correct that data for that email only. And URL, I am trying to every day email URL have to check for the phishing.
But what have you passed as the input to your system? If you're talking about email and web services, so if
Yes,
you're saying that 2
ma'am.
GB data you have collected as an email, so what have you passed as the input?
Ma'am, it is not implemented yet system. It is just a survey. So I'm just trying to reach much more data like email, URL, and messages or like that things which
But if
are
it's a survey, then how
dynamic.
did you get the accuracy? If it is a survey,
It
then
is,
how did you got the accuracy?
ma'am, the
And
papers are given accuracy between the previous models. So email, text contents, and metadata attachments. So that type of data can be used for already used in their system. They have given accuracy in the references. So that's why I'm
okay,
telling.
okay.
Okay, thank you so much for your presentation, ma'am.
Thank you, sir. Thank you, ma'am.
Yes, we can move on to our next presentation, which will be done by Sheetal Wagmare, also from the Marathwada Mitra Mandal's College of Engineering in India. And the title of the research paper is An Empirical Analysis of Various Techniques for Object Detection and Video Summarization from CCTV Surveillance. Ma'am, I request you to kindly start presenting, please.
Sorry.
Ma'am, you are not audible.
Good afternoon, respected chair, judges, and all participants. Myself, Sheetal Ananta Wagmare, research scholar from Department of Engineering, Marathwada Mitra Mandal College of Engineering, Pune. Today, I am presenting my research work, object detection and video summarization for a CCTV surveillance system, which focuses on improving the crime detection efficiency. This work is carried out under the guidance of Dr. Swati Shekhapure ma'am. So introduction of my topic is CCTV surveillance systems are widely deployed in a public and private areas for safety and monitoring. However, these systems generate continuous video streaming, which requires the human operators to monitor them. So manual monitoring is not effective because human cannot continuously focus on long durations. Important events may be missed due to fatigue. Rare events like a crime are difficult to identify. So the to address these issues, artificial intelligence techniques, especially machine learning and deep learning, are used for deep learning models such as CNN, ResNet, VGG are capable for automatically extracting the features from image and videos, making them highly effectively for object detection and activity regions. So I have I have I have use the multiple papers for finding out the previous technologies and previous video summarization techniques. In the literature, several approaches have been proposed. Machine learning, deep learning, as well as reinforcement learning, I have checked. And machine learning methods are used to handcraft features but have limited accuracy. Reinforcement learning methods have improved the decision making, but it's very complex. And last one is deep learning approaches. Automatically, it's learn features and provide the better performance. Many research paper focuses on object detection, activity recognition, and video summarization. However, despite improvements, existing methods still face several limitations in real-world applications. So, research gap. So, for the research gap of this from literature review is based on the literature survey. The following research gaps are identified. Existing model struggles to detect new or uncommon objects. Second one is performance depends heavily on training data quality and diversity. Then it's difficult in handling the overlapping object and crowded scenes. inefficient in detection, suitable or slow-moving suspicious activity, and high computational complexity, which affects the real-time performance. These gaps are highlighted the need for a more efficient and scalable solutions. So my problem statement is the addressed problem statement in the work is the CCTV system generates the large volume of video data. Manually monitoring is a time consuming and error prone. So suspicious activities after the resemble normal behavior. Existing deep learning models require the high computational and lack of generation. Therefore, there is a need to design an intelligence system that can automatically detect the important events and reduce the unnecessary data. So uh, I have find out some objectives. The main objective of my work is to study and analyze the existing object. Second, detection detection sorry to develop a deep learning based object detection model. Third, to design a video summarization method that extracts the important frames to integrate both components into a unified system. And last one is to evaluate the performance using the standard matrix. This objective aims to improve both accuracy and efficiency. So, proposed methodology for my research is that uh, first of all, we need to give the input to the system as a video. Then we need to find out the objects from that frames with the help of dual path networks. Then the frame sequences extraction for every object. After that, we need to do the video summarization with the help of technique that is a Kajuna advisor. With the also we can use the CNN and pyramid dilated attention network to find out the crime. This is a crime or not. It is normal activity or a crime activity. So CCTV video is taken as an input for a processing. Frames are extracting and prepared for analysis. Then object detection and deep learning models are used to detect the objects such as a human, vehicle, suspicious items, activity analysis. The system identified abnormal or suspicious behavior. For video summarization, only important features or events are selected, reducing the video length and output generation. Final summarized video or alerts are generated. This approach reduces the manual efforts and improve the surveillance efficiency. So results of our multiple papers that have uh, displayed in geographical ways. So, in this graph shows the distribution of techniques used in previous research papers. So, 56% use the deep learning, 12% use the machine learning, 8% use the reinforcement learning, and 24% use for other methods. So this clearly indicates that deep learning is the most preferred approach due to its high accuracy and performance. Also, I have displayed that in a graphical way. Uh, this shows the multiple tools used for the implementation. So they have used multiple tools like Python, TensorFlow, and OpenCCTV, etc. So Python is widely used due to simplicity. PyTorch is popular for deep learning model development. These tools provide the flexibility and strong community supports. Then this analysis shows the most research work is recent, especially in 23 to 25. Uh, various performance metrics are used the accuracy, precision, and recalls. So at the end that concludes the object detection and video summarization plays a crucial role in enhancing the effectiveness of a CCTV surveillance system by identifying the important events and reducing the volume of data to be reviewed. Traditional methods have been widely used for these tasks, but faced several difficulties in handling the complex environment. Worrying highlights conditions and high computational demands. These challenges result in lower accuracy and efficiency, especially the dynamic and crowded scenes. This survey reviews 25 articles related to object detection and video summarization from CCTV surveillance, categorized them based on methodologies approaches like deep learning, machine learning, and reinforcement learning. The detailed analysis of each model provided the consideration considering the tools and framework used, performance metrics, publication years, and data sets employed. The evaluation shows database deep learning based methods are the most commonly applied approach. Moreover, Python and PyTorch are the identified as the predominant tools, and some data set is frequently used by the articles. In addition, accuracy is the most widely adopted performance matrix. This comprehensively review the encourage researchers to develop advanced deep learning techniques that can automatically extract meaningful features from the video data, enhancing detection accuracy, reducing the manual efforts, and improving the efficiency of object detection and summarization of CCTV surveillance systems. So, all about my review paper. Thank you. Thank you, sir.
Okay, thank you so much, ma'am. Dr. Shivari, any questions for her?
Yes. How many videos have you been tried currently, or it's just a survey or review? Is
Ma'am,
the
your
implementation
voice was
done?
cracking just a little bit. Can you repeat your question, please?
Yeah. Now is it okay? Am I audible?
Yes, ma'am. Yes, yes, you are.
Yes. I wanted to ask that how many videos have you been tried, or any particular input you have taken for this implementation?
No, ma'am, this is used for only review purpose. Actually, I want
Okay.
to use the videos for detection and summarizations.
Okay. Okay. Thank you.
Thank you, ma'am.
Okay, thank you so much for your presentation, ma'am. We can now
Thank you,
move
sir.
on to our next presenter for today. So our next presenter is Fernando Latour from the Conectate Soluciones we Aplicaciones in Spain. And the title of the research paper is Federated Digital Twin Catalogs, a Split Trust Architecture for Secure Data Publication. Sir, I request you to unmute yourself and start presenting.
Good afternoon. This presentation explains a split trust architecture for protecting subject identifiers in federated digital twin datasets. Wait a second, sorry, excuse me. Okay. The main problem is simple. Organizations may want to contribute data for research, analytics, or secure data spaces, but they cannot expose the real identifier of the subject. So the question is, how can data be linked across systems without revealing the real identity? Our answer is a layered model with functional separation between the clinical system, a local pseudonymization service, an aggregation service, and the publication layer. The first protection step is where in the level 0 is where the place where the real patient data and the original identifier exist together in operational use. In other words, this is the level closest to the real identity of the subject. The key point is that the real identifier should not leave this environment in plain form. So level 0 is where the identity exists, but not where federation should begin. This protection step is in the level 1 is the first protection step. And is not is in the first protection step is not embedded in the edge cell itself in the electronic health records. Instead, the level 1 is a separate service controlled by the organization's IT team. This separation is important because it creates a functional security boundary between the clinical system and the federation architecture. The electronic health records keeps the real identity and clinical operations, but the level 1 service handles pseudonymizations before data is used outside the core environment. It's important to explain HMAC clearly. HMAC is not encryption, doesn't allow someone to decrease the stored value and read the original identifier. Instead, it is a keyed one-way function. The service can hold the secret key. The service that holds the secret key can verify whether a given identifier corresponds to a stored protected twin identifier by recomputing the HMAC output with the same key. So HMAC supports verification, not direct recovery. And this is why an attacker cannot simply read the protection value and reverse it. At level 1, the organization tests the internal identifier and applies the key function as HMAC. And in this way, the secret key is only known by the organization and should be protecting its sound secure environment. The result is a local pseudonym, and this pseudonym is stored in the organization digital twin database instead of the original identifier. So the first layer already reduces exposure because the local database no longer needs to hold the original identifier in operational use outside the electronic health records. This is the first pseudonymization boundary. In the second security layer, an aggregation service receives the level 1 pseudonym and applies a second key transformation. The second secret is different and is controlled by the aggregation domain, not by the original organization. The result is the federated chain identifier. This identifier supports cross-organization aggregation without exposing the original internal identifiers. The aggregation service can also remove free text and retain only coded clinical data before building the federated dataset. So the aggregation layer does not use electronic health records identity directly, and it does not rely only on the first local pseudonym. Instead, it creates a second protected layer for federation. This is the core split trust idea. Now imagine an attacker access the aggregated database at level 2. Again, they do not see the original identifier. They only see the federated digital twin identifier produced by the second transformation. To go further, the attacker will need the level 2 secret, but this is still not enough. They will also need the level 1 secret from the original organization. And even then, they will still only reach the organization internal identifier, not the real personal identity. So one breach at the aggregation level is still not enough for re-identification. This is what I explained. Basically, is recovering internal identifier is not the same thing. First, the internal identifier is inside the organization. Then the mapping inside the clinical EHR internal clinical system is missing, so real identity is protected. At level 3, the aggregated dataset or its metadata can be published in a data space or catalog for controller discovery. This level is less about the core cryptography protection and more about discoverability, governance, and secure access to aggregated datasets. In other words, level 3 is where datasets can be found and described safely without exposing direct identifiers. This can support secure search, governance sharing, and interoperability in federated environments. So from a security perspective, the most important logic is maintaining mainly in levels 1 and 2. Level 3 is mainly the publication and catalog layer. In summary, level 0 is where the real identity exists. Level 1 protects it locally through a separate pseudonymization service. Level 2 protects it again for federation through an independent aggregation layer. And this architecture is strong because it combines multiple transformation with functional separation. So a bridge at one layer is not enough because to re-identify a subject, an attacker will need to compromise multiple independent levels and still access the original clinical system. So the model supports secure secondary use of data without centralizing re-identification capability. That's all. Thank you very much for your attention.
Thank you so much for presenting, sir. Dr. Shivare, any questions for our speaker?
No.
Okay, thank you so much for your presentation, sir.
Thank you.
We can now move on to our next presenter. So our next presenter is J.R. Ashleen Nemo from the Villa College in Maldives, and the title of the research paper is Harnessing AI-Driven Sentiment Analysis for Sustainable Business Decision Making. Ma'am, I request you to kindly start presenting, please. Okay, I think she isn't present right now. So we can move on to our next presenter, which will be Tanmay De from the Symbiosis International Deemed University in India. And the title of the research paper is Sentiment Analysis of Press Releases in the Automobile Sector Using Python. Sir, I request you to start presenting, please.
Yeah, sure. Just give me a second. I'll upload the.
Sure, sir.
Is my screen visible?
Yes, your screen is visible and you are audible as well.
Warm greetings to one and all present in this session. Today, in this conference, I will be presenting a paper titled Sentiment Analysis of Press Releases in the Automobile Sector using Python. This paper has been written by 3 authors. I am presenting. I am from SIPM Hyderabad. My co-authors are Dr. Vimal Kumar and Dr. Pratima Verma. To start off with why we are doing this on the press releases of automobile sector, the reason being what we discovered was the automobile manufacturers were operating on a split personality. And how we look at that split personality is they were manufacturing both EV vehicles, electric vehicles, as well as the traditional combustion engine vehicles to the customers. And that triggered something in us. How are they communicating to the customers, and how the PR releases when they launched their product, or they were communicating with features of the products, they were releasing PR notes. So we tried to look at those PR notes through natural language processing models and try to connect with certain key terminologies where we looked at the SDGs and the subjectivity of the content of the text which they talked about. And then we also looked at theoretical perspective of building in a linguistic gap using Daniel Kahneman's dual processing theory to prevent greenwashing accusations and build a unified, trustworthy corporate voice from the automobile sector. So what was that which was contention for this research was how these two transformative understanding of the engines. One was the very traditional one where we used petrol or diesel as a fuel, whereas EVs started coming in with the concept of looking at environmental safety and environmental concerns that was raised. So what happened was they had a fragmented brand identity. When we say that manufacturers, when they were promoting EV or the non-EV vehicles, they were a fragmented brand identity running in two different fundamental discontent PR, connected PR strategies, invite stakeholder skepticism that diluted the overall corporate trust. So the analysis was done as an analytical engine, we call it, and 4 steps. One was the ingestion, where we tried to extract a number of PR communication materials from these companies. And then we tried to look at what they did. So we had 3 companies. For the confidentiality sake, we are not naming it. We have named it as TM, D, and MM, all operated from India. And this was taken during the period of 2020 to 24. Next, we went for refining through tokenization and a natural language toolkit to reduce complex marketing language to root mathematical forms. Then we gave a score on polarity, that is from -1 to 1, and subjectivity to 0 to 1. Then we tried to look at the SDG alignment of how this the goal and scope of this automobile manufacturer were aligned with the SDG requirement. The thematic divide, which we clearly found out, was about how the electric vehicles communication focused on environment. And also to some extent to the economic focus, 37.5%, where the dominant keywords were sustainability, innovation, and clean energy. Whereas traditional vehicles were still talking about performance, technology, reliability, family, safety were the dominant keywords. Environmental mentions somehow was not very clearly coming out, and then the EV messaging was towards more of a global citizen. So this was what we mapped it as far as the opinionity subjectivity was concerned, and positivity on the polarity part was concerned. There were companies which, so what we did is to tell you in detail. For one company, we had their EV. So these 3 companies manufactured both EV and non-EV. So for we had taken 2 from non-EV PR material to EV PR material from the companies. So overall total, there were around 12 materials we had picked it up that made sense to our research on how we are looking at the content without whether it is neutral, factual, or data driven, or it is heavily subjective opinions. So if you see a non-EV was more of a subjected, most opinionated subjectivity was high in this, whereas EV was more neutral of how they were promoting the things in polar positivity terms. As far as SDG alignment was concerned, the EVs talked about SDG 11, 7, 9, and 13, more on innovation, energy consumption, climate actions, and how urban landscape, urban cities, smart cities were to function. Whereas for the non-EV part, we had almost 20%. And so overall, if you look at it, except for innovation, they were all lacking. And obviously, climate action was not spotted in the non-EV part. So the architecture of message was very clear of how the depth of the analysis was of an engineer's voice of EV, and the driver's voice of non-EV was there. And automakers were inadvertently wearing these sentences to trigger 2 entirely different human cognitive responses. So we talked about from the cognitive responses where we saw something on the danger zone. So the narrative fracture was there of how pushing climatic action in EV press releases were maintaining a 0% alignment with climate action in traditional vehicle communications. Creates a fractured narrative on the non-EV part. The business threat was whether there was chances of selective sustainability as greenwashing, applying an eco winner to a portion of the fleet while ignoring the emissions reality to the core business. That led to the cognitive map of Kahneman's dual process theory. As far as the theory is concerned, there are 2 systems that Kahneman talks about. One, a fast, emotional, and instinctive, that is system 1, driven by nostalgia. So more of emotions, identity, and convenience perfectly match the current non-EV PR data. Short sentences, high subjectivity. Whereas System 2 was slow, analytical, and deliberate. Engage logic, metrics, and effort reasoning. Perfectly matches the EV data, long sentences. So we had to get into that insight to fix the narrative divide. Brands must stop separating these cognitive systems and start weaving them together. And then we suggested this to look at as the EV playbook. So what we tried to look at with how we can optimize the system 1 and the system 2 data to have a maximum reach. So it was more of how it was earlier. So before, if you look at it, only system 2 was there. Then it says this vehicle achieves a 40% reduction in tailpipe
Excuse me,
emissions.
sir.
Yeah.
Sorry to interrupt, but just wanted to remind you, you have 2 more minutes left. Thank you.
Yeah. I'll be there. And the optimized one was EV cuts emission by 40%, system 2. So what we did is we tried to build in and suggest that system 1 can be added to it, so your family can explore a clean, quieter city. So this kind of narrative should now come up from the automobile manufacturers in India who are into both EV and non-EV. There's another set of things which we try to bring out as far as system 1 emotions and system 2 data are considered. So system 1 only was talking about building for a rugged family adventures and unparalleled reliability. We again optimized it, saying that not only rugged terrain, you can have improved fuel efficiency verified by independent testing. That leads to the corporate integration matrix as far as practical verification, social equity and managerial protocols are concerned, where we could have we can take it further for more application in blockchain, tracking publicly published supply chain metrics, link sustainability narratives to social equity. And for managerial, there has to be protocols on how we are using for greenwashing risks and all. The last part of it is where do we take it forward? When we say that the baseline intelligence reflects text from TMD and these are the three companies, it captures highly curated official corporate posturing. The next frontier, if we have to look at a future aspect of it, how we can integrate real-time social media sentiment analysis, consumer feedback loops, computer vision to analyze non-textual brand imagery. That's how we are now looking for a more of a unified engine, which we'll talk about. Automotive future is not about changing the hardware under the hood. It requires changing the engine of the narrative. So thank you for giving me an opportunity. I'll stop sharing. Any questions, please go ahead.
Thank you so much for presenting, sir. Dr. Shivari, any questions for him?
Yes. What is the application of this?
Pardon?
What is the application of this?
Okay,
Yes,
so
hello,
this
am I audible?
application
Yeah.
is the implications are majorly for the automobile manufacturers who are now actually having all the options with them, like a hybrid and option of petrol plus EV or a diesel plus EV. So we are telling them to how to blend this communication narratives in the PR communication. So generally, when they launch new products, which is having a blend of ICT plus the EV part, so they will be more careful of how to drive this together.
Okay,
So
have you thought of combining social media or reactions also with your
no, we have not. We have
press
only
release
captured the
for
PR
better
materials which
sentiment
officially came up. PR material which was officially they have come out with. The company has come out with this PR material. So no social media information or data has been taken for this study. That's what we mentioned in the future scope, that we might take social media mentions also.
Thank you.
Thank you. Thank you, ma'am.
Thank you so much for presenting, sir. We now move on to the next presentation. So our next presenter is Sarayu Gayatri from the Satyabama Institute of Science and Technology in India. And the title of the research paper is Smart Garage Security and Monitoring Using IoT. Ma'am, I request you to kindly start presenting, please. Okay, I think she isn't present with us at the moment. We can move on to our next presenter, which will be Ashavari Das from the Higher College of Technology in the United Arab Emirates. And the title of the research paper is the impact of short-form video platforms on social media marketing strategies. Ma'am, I request you to kindly start presenting, please.
I said, good afternoon. My name is Dr. Sambram. I am the one who is going to present on behalf of Dr. Asha. I am one of the author.
Okay, you are one of the co-authors, right?
Yes, sir.
Okay, sure, sir. You can start presenting, please.
Yeah, thank you. Is my presentation is visible, professors?
Yes, sir. Your presentation is visible
Okay.
and you are audible as well.
Thank you. Good morning, good afternoon, wherever the part of the world it is. I am from UAE. The impact of short-form videos platform on social media marketing strategies. My name is Sambram. I am one of this co-author for this paper, and I'm from Amit University, Dubai. If you see now these days, all the social media platforms, you take anything that TikTok, it's the Reels in Instagram or anything, this is very much in demand. So what we have done is we have proposed an integrated framework combining that is called BVQ, blind video quality assessment, and generative enhancement to optimize short form content. We have drawn the insights from effective computing and recommender system, which is very necessary to see that which video is coming to the next by seeing your by knowing your the details from the login details. Our research explores how authenticity is lo-fi aesthetics and influence credibility drive consumer engagement and brand innocence in evolving digital economy of nowadays. We have done this through algorithm engagement and a multimodal content strategies. The digital marketing, as you know, landscape has rapidly evolved with the rise of short-form platforms. And our study reveals that digital marketing is revolving these platforms favor quick, engaging the content supported by advanced algorithms. These enhance user engagement through data-driven strategies. We emphasize the growing importance of multimedia elements and authenticity. There are many, we found out the problems integrating storytelling is become crucial in building brand loyalty. Because anytime the viewers goes or the customers goes, they always see what is the value of the brand and how is the long lasting. However, the challenges remain, such as outdated evaluation metrics and balancing authenticity and professionalism. We have addressed this issue. We propose a structured framework that focuses on advanced video quality, generative enhancement, and multimodal alignment to optimize marketing on these platforms. So our objective is to examine how the rise short-form video platforms has transformed digital marketing strategies from social graph-based approach to interest graph-driven models. And the second one is to analyze the effectiveness of lo-fi authentic content and the hook value CTA structure in enhancing audience engagement and emotional connection. And the next one is to evaluate the role of multimodal marketing techniques, visual, audio, and speech elements in influencing brand association, purchase intent, and user interaction. The fourth one is to investigate the impact of real-time analytics and platforms-driven insights of content optimization, campaign adaptability, and marketing performance. And the last objective we have is to assess how SFB short video platforms influence consumer trust, brand credibility, and long-term loyalty, particularly among Gen Z audiences, while measuring return of investment, that is called ROI. Our methodology is utilizes a multimodal marketing framework that merges blind video quality assessment with generative enhancement to assess and enhance short-form video performance and memorability, leverage insights from effective computing and recommender system to link technical signals, visual, audio, speech with strategic outcomes, such as brand association and purchase intent. Implement a driven interest graph model we have used, that is G equal to within bracket U, I, E, using weighted engagement metrics to predict content relevance and ranking. We test the model with behavioral data from Gen Z, millennials, and Gen X, supported by market trends and analysis of user for preference and influencer trust. The rise of short form video. If you see, the rise of short form video platform is fueled by the demand of snackable content and advance in mobile technology like 5G, which enable smooth, high quality viewing on smartphones. And there is a shift from social graph to interest graph, with AI recommending content based on user behavior for personalized engagement. Platforms like TikTok, Instagram Reels, and YouTube Shorts promote democratized virality, where visibility relies on trends and users' engagement rather than the production cost. Marketing strategy favor authenticity and unpolished aesthetic, focusing on short vertical videos that quickly capture the attention. Marketers' engagement metrics like watch time and rewatch rates using shoppable video to like content, consumer behavior, and e-commerce. This is what we have used for our methodology, and after that the core. The core characteristics of engaging video content, how the core characteristics has been engaged. If you can see this table, this highlights the key elements that improve the effectiveness of short form video in digital media. Important components include an attention grabbing hook that is concise, of value, and clear call to the action. The CTA is most important because what happens is if anyone like, share, or comment now, the backend team should go ahead and contact them, that whoever is interested. And another important is the platform optimization. The content like TikTok and Reels, they improves algorithmic reach. You can see that who and how many of your audience or your viewers from which part of the world has connect with you. What we have to use, we adopt an interest graph strategy for our current marketing strategy, where the content is recommended based on the real-time user behavior, such as watch time, completion rate, and shareability. By continuously analyzing these metrics and leveraging AI-driven tools, we enhance both content quality and performance, effectively balancing authenticity with professional clarity to maximize the engagement. So what we have done is we have used this algorithm, which R of U and I, which represents the relevance score. It is calculated as alpha 1 times T1 plus alpha 2 times CI plus alpha 3 times S1. This is what we have used, and where the C1 is the completion rate, shareability index is the SI, and the alpha tunable weight using regression of gradient based optimization. So as we know, the modern brands should view these platforms not just as social media channels, but as integrated search and discovery tools, where the algorithms preference for vertical fast-paced content demands a complete overall of production workflow on this. And how it has been impact to the consumer behavior and engagement. If you see, this graph highlights the strong impact of short-form video on consumer behavior, especially in terms of engagement of brand trust. We can see around 85% of users prefer short-term videos over long-term content, because audience doesn't have that much time to see this. If they like your video, yes, they will go for the longer version of this, or else they will scroll to the next one. We can call a digital dependency model, where entertainment and perceived value drive interaction. It is also shows that short-term video acts as a powerful discover tool, with nearly 70% of viewers feeling more connected to brands, and over half of them being influenced in their final purchase decision. Yes, sir.
Sorry to interrupt, but you have 2 more minutes left. Thank you.
Yeah, sure. I'll finish before that, sir.
Okay.
This is the key advantage which I wanted to discuss over here. In our approach, short-term video acts as the core driver of the organic growth, where platforms algorithm helps increased visibility and reach. This leads to higher audience engagement, not just through views, but also through action like sharing and user-generated content with the scan. Over time, this engagement helps transfer influencer credibility to the brand, gradually moving consumers from simple awareness to building the trust with the brand. And what are the challenges the content creators faced and the strategy while the education? Creating effective short-term video content come with several challenges. Brands must capture attention first, which quickly with engaging and visually appealing content, while also balancing creativity with clear brand messaging. Then as a marketer needs to be interpret analytics and audience behavior correctly to improve performance. Finally, this is adapting to different platform algorithms and rapidly changing trends while maintaining brand consistency. That requires constant flexibility and coordination. And this is the conclusion part. Let me tell you that we find out in conclusion, our study shows that the short-term video platforms have transformed digital marketing by shifting the focus from social connection to interest-based content. This change encouraged brand to adopt authenticity of lo-fi content, create quick emotional connections, and follow a hook value approach. Instead of relying on high production formats, we also find that combining visual, audio, and speech element, wherever the video we have checked, that has to be video, the visuals, and that has to be audio as well as the background speech, which we call the voiceover, along with real-time analytics to their strategies. Ultimately, we find out that the success in this space depends on how well brands adapt to platform trends, build trust, especially among the Gen Z, because they are the one who is surfing the net most of the time, and balance creativity with data-driven decision. This is our findings, and I love to take if there is any questions from the respected panel.
Yes, thank you
So
so much
what are
for
the
presenting, sir.
implications? Yeah.
Sorry, come again, please, Doctor.
Yeah. What are the implications of your study or benefits or advantages?
Okay, so ma'am, what happens is we wanted to see that the short-term videos which was first started by YouTube, we wanted to say that has been taken over by TikTok as well as with Instagram. We wanted to find out that why this is most important and why most of the viewers are going ahead for the short-term videos instead of the long-term videos. So what we found out that most of this Gen Z, 85%, they love to see the short-term videos, which has the video, visuals, audio, as well as the background voice.
Thank you.
Okay, thank you so much for your presentation, sir.
Thank you, everyone. Have a good day.
Yes. Well, that brings us to the end of technical session 12F. I now request our session chair, Dr. Chaitali Shivare, to give us her closing remarks.
Yes. So first of all, thank you, ICTIS, for inviting me as the session chair for this conference. And all the presentations were very nice, beautiful, and study also was very good. So I'm thankful for you all to invite me. Yes.
I'm so sorry, ma'am. I have completely missed out on one presentation that we were supposed to take. I apologize. We have one last presentation before we leave. Give me just a second. Yes, so one of our previous speakers has come back right now. She was facing some technical issues. The final presentation will be done by Sarayu Gayatri from the Satyabhama Institute of Science and Technology in India. And the title of the research paper is Smart Garage Security and Monitoring Using IoT. Ma'am, I request you to please start presenting.
Uh, Good evening, good afternoon, everyone. I am here to present my paper about smart garage security and monitoring using IoT. This project presents an IoT-based garage monitoring system that improves residential safety and convenience. It uses an ESP32 microcontroller with Wi-Fi connectivity to monitor garage in real time. An ultrasonic
Excuse me, ma'am.
sensor. Yes.
Are you sharing any PPT because we can't see anything?
1 second. Uh,
Yes, it's
uh,
now visible. You can continue.
I am using an ultrasonic sensor to detect the presence of vehicle by measuring the distance. A magnetic switch checks whether the garage door is open or closed. The system employs a smart logic to notify users if the door is left open too long or open when no car is inside, helping to prevent theft. Additionally, a motion sensor can be added to detect unusual activity, further increasing the security. The objectives of the proposed work is to detect the presence or absence of a vehicle using ultrasonic sensor, monitor the door open or close status of the garage door through a switch, notifying the homeowners if the garage door is left open for an extended period. And it also provides updated notifications via internet connectivity. Uh, this is the architecture of the model. We are using two ultrasonic sensors. One will be outside the garage and the other will be inside the garage. Pair motion sensor is used to detect any anonymous activities are happening inside the garage or outside the garage. Magnetic switch is used to detect the door is open or not, and the servo motor is used to open the door. It is all connected to the mobile application using Blink app, through which we can control the garage and receive notifications. We can use batteries for power or external. We can use batteries for powering the model. This is the list of modules. Module 1 is vehicle presence detection. Module 2 is garage door status monitoring. And module 3 is motion detection. And 4 is about decision making logic. And 5 is IoT communication module setup. And 6 is about sensor integration and data acquisition. And 7 is alert and notification system. And 8 is user monitoring interface. And module 9 is system testing and validation. And the proposed system is an IoT based garage security monitoring system that ensures reliable and real time monitoring. The system uses an ESP32 with Wi-Fi to transmit live data from the ultrasonic, magnetic door, and motion sensors. It provides stable connectivity and quickly detects abnormal activities with the help of motion sensor in the garage. The system supports remote monitoring, allows user to check through the Blink mobile application. The system automatically detects unauthorized garage door opening and unexpected vehicle movement. It reduces the need for manual monitoring and improves the convenience for homeowners. This is a cost effective and suitable solution for residential garages. Thank you.
Okay, thank you so much for your presentation, ma'am. Dr. Shivare, any questions for our speaker?
No.
Okay, thank you. Thank you so much for your presentation, ma'am.
Thank
And
you.
now we finally come to the end of technical session 12F. Ma'am, I request you once again for your closing remarks.
Yeah, first of all, I'm thankful to ICTIS for inviting me as a session chair for this conference. Also, all the presentations were nice and all the best for your future study. Thank you.
Thank you so much, ma'am. I sincerely thank all of our authors for their excellent presentations and contributions towards this session, and also all of our participants for being a part of this conference. I hope this session was informative and knowledgeable enough for all of us. And on behalf of the entire team, I would like to thank all of you for the support you have shown during the 11th version of this conference. We will be more than happy to host all of you again in 2027 for the 12th version. A small announcement, all the presenters will be getting their digital certificates via email within 2 to 3 working days, and the publications will be live within 7 to 8 months. So kindly cooperate with the team of ICTIS. I also thank our session chair, Dr. Chaitali Shivare, for chairing this session. Uh, thank you everyone for your valuable presence. I have one small request. Can all of you please turn on your cameras for a quick snapshot of this conference? Okay, and we're done. Thank you so much, everyone. Have a great day.